And now we get to accuracy and precision. Number 27, explain the difference between accuracy and precision. Accuracy refers to how close a value it is to the true value. So if something's supposed to be 5 grams and you weigh it and it's 5.1, then you know it's pretty accurate. If it says it's 8.9, then it's not very accurate. Precision, there's two definitions for precision. One is how reliable a measurement is. Can you get that same number over and over? The other definition is how much information is given in a number. 0.12 is more precise than 0.1. Because we have more information, we go all the way out into the hundredth spot versus just the tenths. 855 is more precise than just 800. And then they ask you to devise a scenario. The scenario here, where something is precise but not accurate. Imagine the true mass of an apple is 5.80 kilograms. The apple is massed on a scale 4 different times. And the scale reads 4.20, 4.19, 4.20, 4.21. Those values are pretty close. They're pretty precise. We keep getting roughly the same numbers over and over again. So the values are precise, but they're not accurate because they're not close to the accepted value. The accepted value is 5.8. 28 says, how can you use the Atlantic Pacific rule to determine the correct number of sig figs? This is an easy way as long as you know which ocean's where. Here's the Pacific, here's the Atlantic. First rule says, look at a number, decide if the decimal point's absent or present. If it's absent, you're going to start on this side. If it's present, you start on this side. If the decimal point's absent, start from the Atlantic Ocean side and count in towards the left. So you're going to go in this way into a number. If it's present, you're going to start from the Pacific Ocean side and count in this way. And then you start counting with your first non-zero digit. So for instance, let's say I have this number, 100. The decimal point is absent. I don't see it. So I'm going to start from the Atlantic Ocean side and I'm going to count in. It says start counting with the first non-zero digit. So I don't count my zeros. I start counting here and then I count until I run out of things to count, which I did. So there's only going to be one sig fig here. What if I had 100.0? That changes the rules because now the decimal point's present. I start counting in this direction. I start counting with the first non-zero digit, which is a 1. I keep counting till I run out of things to count. So the 1, 0, 0, 0, there's 4 sig figs there. Okay. Number 29, how many sig figs are in the following numbers? Decimal point's present, so I count from the Pacific Ocean side. I can't count any of my zeros. I start counting with the 3, and I count till I run out of things to count, which I did right away. B, decimal point's absent, so I start counting in this direction. I can't count any of these zeros. I start with the 9, and I count till I run out of things to count. The 9 and the 8 count, there's 2. Scientific notation, ignore this. Whenever you have scientific notation, ignore that. Decimal point's always going to be present. Come in from this side, and you've got 3. And over here, it's present. Come in from this side. 1, 2, 3, 4, 5. They all count. Okay, the next two questions ask you about the differences in the rules that you're supposed to use when you multiply and divide and when you add and subtract. Now, the multiply and divide is a little more complicated because you have to understand how to count sig figs, the stuff that we just did. This one, adding and subtracting, is a little bit easier because I could probably walk into a second grade classroom and teach them how to do this as long as they can identify where the decimal place is and look at the number of digits to the right of the decimal. So for instance, this one's got 2, this one's got 1, this has got none, this has got 2. So as long as you can do that, you can do this bottom one. This one's a little more complicated. Let's start with this. What rule do you follow? Well, when you multiply and divide, you have to look at the values in the problem with the least total number of sig figs, the least total sig figs, and then you're going to round your answer so it has the same amount. So let's look at this first number. This is 45.00. So there's 4 sig figs here because I come in from the Pacific side. I start counting right away because that's non-zero. I count 1, 2, 3, 4. I count till I run out of things to count. So there's 4 sig figs there. Then this one, 8.0, I also come in from the Pacific side. I start counting with the 8 and then I count 2. So 2 is less than 4 and my answer is going to have 2. So I do out the math on the calculator. The calculator comes out to be 360. I can't just write that down unless I'm sure of how many sig figs that has. Now this one, written just the way it is, no decimal point, we come in from the Atlantic Ocean side. The 0 doesn't count, the 6 and the 3 do, and that, just like it's written on the calculator, happens to have 2 sig figs. If I needed 3 sig figs, then I would put a decimal. I would write 360 with a decimal point. Now that means I come in from the Pacific side and I count 1, 2, 3. If I needed 4 sig figs, I'd put the decimal point and I'd add a 0, and so forth. If I needed 1 sig fig, I don't, I need 2. But if I needed 1, I would take the number off the calculator, the 360. I would take this number and say, well, let me keep the biggest place. And let me look at that 3. Should I keep it a 3 or round it up? I look next to it. That 6 tells me take that 3 and round it up to a 4, and then make everything zeros. So it would be 400 if I needed just one sig fig. Okay? Let's look at this example. This has got 2, because I come in from the Atlantic Ocean side, no decimal point, just the 2 counts, so there's 1 sig fig here. Over here, I come in from the Atlantic Ocean, or the Pacific Ocean side rather. None of the zeros count. 1, 2, 3 count. So I've got 3. 1 versus 3, my 1 is going to win out because that's less. I'm going to have 1 in my answer because my answer has to match the least total. So I do out the math, and my calculator, which knows nothing about sig figs, gives me 6, 9, 8, 8.02395, yada, yada, yada. So we have to take this big mess and round it so there's only 1 sig fig. We have very low uncertainty with this 20 here, so we're going to have the same amount of uncertainty with our answer. So we're going to pick the biggest position, the biggest value, and we're going to say, what do I do with that 5? Do I keep it a 5 or do I round it up? You look next to it, there's a 9 next to it, so that 5 gets rounded up. Now I can't take this big number, 5,988, I can't take that and round it to 6. That doesn't make any sense. But I can take this big number and round it to 6,000. The other way I could have done that is I could have taken that 5, rounded it up to a 6, and then written times 10 to the 3rd to keep the 3 places here. Okay? So either way, come in from the Atlantic Ocean side, this has got 1, or come in from either way, Atlantic or Pacific, and we've only got 1 digit here. Because remember when you do scientific notation and you're figuring out sig figs, the scientific notation never counts. Just look at the 6. Alright, so that's the more complicated part. You have to look at the values in the problem and pick the least total. Down here, this is what a little kid can do. We just line up the decimal points and look at how many digits are on the right. So over here we have 2 on the right, here we have 1 on the right. This one's least, so our answer is only going to have 1 on the right. So when I do out my math, my answer is going to be 53 on the calculator. Calculator does not understand sig figs, so we're going to end up with 53 and then adding a 0.0 because we need to have 1 digit to the right because our weakest measurement has 1 digit to the right. Over here, we have no digits to the right, and we have 2 digits to the right. So our answer is going to have no digits to the right. So when we do out the subtraction here, the calculator, which knows nothing about sig figs, gives us 19.66. We're going to round that so there's nothing to the right of the decimal. We're going to take that 6 before we lop it off. We're going to take that 9 and round it up. So it's going to be 19 gets rounded up to 20, and then the 66 gets dropped off. Okay? Doesn't matter how many total sig figs this one has. Just the fact that there's nothing to the right is important. Okay? Now let's try measuring, using devices and measuring correctly with the right number of sig figs.